constants for zero dissipation. 9 constants for zero dissipation. Right? Zero dissipation. Line constant. Today we will discuss line constant for zero dissipation line. Zero dissipation line. Right? For the transmission line, line constants for line constants for transmission line Z is equal to R plus J omega L. We know that Z is a series impedance of the transmission line, where the R is resistance per unit length, L is the inductance per unit length of the transmission line. Then the shunt admittance is G plus J omega C, where G is the conductance of the transmission line per unit length and C is the capacitance of the transmission line per unit length. Right? We know the characteristic impedance. The characteristic impedance Z naught is equal to root of Z by Y. Root of Z by Y. So the root of Z by Y, that is Z is equal to R plus J omega L. Y is G plus J omega C. G plus J omega C. Right? The propagation constant gamma is equal to root of ZY. The propagation constant gamma is equal to root of ZY. We know the gamma is equal to alpha plus J beta. Where alpha is the attenuation constant of the transmission line and beta is the phase shift of the transmission line. Right? So the gamma is equal to, substituting, the gamma is equal to root of R plus J omega L and G plus J omega C. For zero dissipation line, the consider R is very small. For zero dissipation, R is very small compared to the reactance, compared to the inductive reactance, and G is 0. Assumed conductance G is equal to 0. Right? Equal to 0. So that your characteristic impedance Z naught is equal to root of R is very small then compared to the inductive reactance. So R is neglected. J omega L divided by G is equal to 0. Only J omega C. So J omega cancel. Z naught is equal to root of L by C. This is a zero dissipation line characteristic impedance. The zero dissipation line characteristic impedance Z naught is equal to root of L by C. So the propagation constant of the transmission line gamma is equal to root of J omega L. R is very small compared to reactance, inductive reactance, so it is a neglected. J is equal to 0. So J omega L and J omega C, right? That is equal to minus j squared, it is a minus 1, minus omega squared LC, we write j omega root LC. It is a gamma. It is a gamma. We know the gamma is equal to alpha plus gamma is equal to alpha plus j beta. Alpha plus j beta, where alpha is equal to attenuation constant. Alpha is equal to attenuation constant, beta is the phase shift of the transmission line. So in the terms, the propagation constant only j omega term only, j term only. So it is the imaginary terms. So alpha is equal to the attenuation becomes alpha is equal to 0. So attenuation constant is equal to 0 for dissipation less light. Alpha is, the attenuation becomes 0, alpha is equal to 0. The phase shift beta is equal to only for imaginary term j. It is a omega into root LC. Omega into root LC. So the alpha is equal to 0. Attenuation is a 0 for dissipation less light. It is our 0 dissipation light. Thank you.